Hello. I know I said I did not have time to do a test review video this unit, but since we postponed the test for a couple of days, I have time. So I want to go over maybe some of the problems that you need to work on as far as like the application type problems. But these type of problems right here, the fill in the blank, I'm not really going to go over because I did give you the answer key online, so you can just fill in these. These are more vocabulary. It's not really quite the type of questions that you would be benefited if I just wrote down the answers. So it'll be just as beneficial if you go onto Moodle, Unit 6, scroll down to Test Resources, you'll see the review and you'll see the answer key here. There. So first thing I want to talk about is kind of the overall topic of this test. So naming compounds is the topic. So all we're doing on this test is naming ionic, covalent, and acid compounds. So first you need to decide whenever you're seeing this these type of problems on the test is whether it's ionic, covalent, or acidic, or an acid. So if it's ionic, you're going to see a nonmetal and a metal together. So for example, sodium and chlorine. So how do you know if it's a metal or a nonmetal? This is from like the beginning of school, but metals are all over here, okay? And then there's that staircase of the metalloids, and then these are all the nonmetals, okay? And don't forget that hydrogen is actually a nonmetal. So you can tell if it's ionic, if it's not a metal with a nonmetal combined. If it's a covalent bond, it's made of nonmetals. So for example, covalent bonds are usually just all of these guys over here, and sometimes hydrogen can be in the middle of the compound, but or the formula, sorry. But if it starts with an H, okay, if it starts with a hydrogen, then that's how you can tell if it's an acid, if you're looking at an acid formula. So if it starts with an H, you can safely assume in 10th grade that it's an acid. If it's two nonmetals, you can safely assume that that is a covalent compound you're looking at. If it contains a metal, then you can assume that it's going to be an ionic compound, okay? So those rules will apply in naming. So let's move on. We're not going to do the first page because all the answers are on Moodle. So we're going to start on the second page, okay, of your review on question 2. So we're actually going to start out with ionic compounds. So also your resources on Moodle are the must memorize list for the polyatomic ions. There are 7 of them. This is available to you under Unit 6, Test Resources, and that's literally the title of it. And then IB test questions, you honors children. You guys will also be tested with IB exam questions on ionic size. So remember that the ionic size, remember the periodic trend, whether it's increasing or decreasing. So there's, I think we went over 3 trends, which was electronegativity, ionic size, and what was the other one? Ionization energy, sorry. So this is just a periodic table trend. It should be in your notes under the periodic table notes. Polarity was last unit that we learned. So the polarity goes along with covalent bonding molecules. So it'll probably be in one of those, it is in one of those PowerPoints if you need to review it. Standard deviation, that's something you guys had a quiz over already, but it's basically the sum of your trial 1 or whatever the first trial is minus the average of all trials squared, all over the number of trials minus 1, okay? And then percent error, that one's easy. That one is your theoretical value minus experimental value, all over theoretical value times 100%. Okay, density, you need to be able to calculate density, be able to manipulate that equation. Remember, density equals mass over volume, be able to solve for volume, be able to solve for mass, be able to manipulate this around, and know the overall concept of it. Okay, so those are topics involved in the questions pulled from IB exams, okay? That's for honors. Then You will have available to you on the test this polyatomic ions sheet minus the ones I asked you to memorize. So this list that's on Moodle, the must memorize list, the 7, I will take them off. So for example, ammonium, I will have a white out on it. Well, not white out, but when I copied them, I made white out on it. But you will have access to all of these, so you didn't have to memorize all of these. Hopefully you didn't, because I've said it many times in class. But you just have to memorize the 7. Polyatomic ions, the rest I'll give you, and then you will have this exact periodic table, okay? The reason this periodic table is so special is because, remember right here, it actually will tell you the charge of the transition metals. So if there's more than one transition metal, that's how you know you'll be dealing with the Roman numeral. All right, so let's get started. So right now we're dealing with ionic compounds, so we have potassium nitride. So potassium is over here, okay? So that means it's in group 1. Group 1 elements have group 1 ions have a +1 charge. So potassium will have a +1 charge. Nitride, if it ends in IDE, so that just means it's nitrogen, okay? If it was nitrate or nitrite, then you have to look on your polyatomic ions list, but it's not. It's nitride, so it's just this one. This is a neutral group, -1 group, -2 group, and nitrogen is -3. So you would just write N with a -3 charge. Now we're going to cross over the charges, okay, and which is my favorite method of doing this. So you're going to bring this 3 down. You're going to bring this 1 down, okay. So then you're going to have potassium. That 3 was brought down, and then the 1 is brought down, but we don't write the 1. So it's just potassium, 3 nitrogen, okay? Moving on, iron 3 sulfite. So iron is actually one of those weird transition metals, and you can tell by looking here that it could be +2 or a +3 charge. So with that being said, in order for us to know which charge it is, we have to look at this Roman numeral right here. It's going to tell us, okay? So I might brush up on my Roman numerals from 1 to 4. You won't really have to go higher than 4. But iron is, again, Fe. Okay, so I'm going to write Fe. It tells me what charge I'm going to use, a +3 charge. Sulfite. Ite is not ide, so we're not talking about sulfur. We're actually talking about a list on the polyatomic ions list, and sulfite is right here, okay? So that means we're going to use the polyatomic ion SO3 with a -2 charge. So we're going to use SO3 with a -2 charge. Then we're just going to bring these down, okay? So that means the answer will be Fe2, SO3. We need to put it in parentheses since it's a polyatomic ion, 3, okay? So if we have more than one polyatomic ion, we need to put it in parentheses. If you have one, you may put in parentheses if you like it to keep organized, but otherwise that's optional. Okay, now we have calcium oxide. So calcium is on the periodic table. Calcium is right here, it's a metal. So it's in group 2, so it's a +2 charge. Oxide, so it's IDE, so we're just talking about oxygen. Oxygen is here, this is a neutral charge, -1 charge, -2 charge. So -2 charge. We're going to bring these down, okay? So technically, at first, it's going to be a Ca2O2, but remember we're dealing with ionic compounds. We're dealing with ionic compounds, so we need to use the empirical formula. Okay, we need to use the empirical formula, and what that just means is that it's reduced. That means that it is reduced. So, and that's only with ionic compounds. Don't do this with covalent. So we're going to reduce this to just CaO, and that's your actual answer. Don't do this on the test. Make sure you reduce these ionic compounds to their empirical formula. That looks like a really good question for a matching question, just saying. Tin is one of those weird transition metals. I think it's like SN. Here it is. Okay, so tin is right here. It could be a +2 charge or a +4 charge. So I don't know which one to use, but there's a way to find out. The Roman numeral, okay? So this is telling me that my 10, which is Sn on the periodic table, is we are going to use a +4 charge. Carbonate, that is not on the periodic table. We have to find that on our polyatomic ion sheet. Carbonate, right here, CO3 minus 2. So I just copy that down, CO3 minus 2. Make sure you remember that this is one that you have to memorize. So if you hadn't memorized it, you wouldn't do very well on the test on this one. Okay, you would have had to guess, I guess. So carbonate is a memorized one, but we have Sn, we have 10 in carbonate, and again, we're just going to bring these down, cross them over, and then we're going to just write the formula. So this is Sn2 CO3. We're going to put them in parentheses because we have more than one, 4. So this is not actually complete because we can reduce this to its empirical formula. So we actually need to write it as Sn CO3 2. That's actually your correct answer, okay? Moving on, we're going to start doing these a little more quickly just to save you some time. So gallium chlorate. So gallium is a transition metal, I believe, or one of those weird ones or in between. Either way, gallium is here, but it only has one possible charge. It is a +3 possible charge. So we're going to put in gallium, we're going to put gallium, Ga, +3. Okay, so that's it. If it had more than one charge, because it is one of those metals in the weird place, it would indicate which charge to use with the Roman numeral. But since it's only one charge, we don't have to have a Roman numeral. Chlorate. If it was chloride, it would be on the periodic table. We'd be talking about chlorine. But since it's chlorate, it's actually on your list of polyatomic ions. Chlorate is right here. Chlorate. It's not one you have to memorize, so we're just going to do ClO3 minus 1. So chlorate, ClO3 minus 1. So now we're just going to, again, just bring down these charges, okay? And we have Ga1, but we don't put our 1. Putting Ga1 is the same thing as saying 3 to the power of 1 or 3 with a decimal point after it. They both actually are saying that they're 3, but we really just assume that and we assume that. So we're assuming this 1 if I put the symbol Ga. So we have chlorate, which is Ga1ClO3, but we have 3 of them, so we need to put them in parentheses, okay? Just like that. Simple. Moving on, zinc oxalate. Zinc is a metal. It is a transition metal, okay, right here. Its charge, it only has one possible charge, which is a +2 charge. So we're going to name it. So zinc with a +2 charge. Oxalate, that is definitely not something on the periodic table, okay? That is going to be something on your polyatomic ions list, which again, you'll have this minus the 7 I wanted you to memorize. Oxalate, here it is. So we're going to put it as C2O4 with a -2 charge. So oxalate is C2O4 with a -2 charge, okay? You can either keep doing this cross method, or you can just look at it and say, we have a +2, we have a -2, they're going to cancel each other out, so it's just going to be ZnC2O4. That you could do it that way. If once you get comfortable, you say, okay, this side's -2, this side's +2, they'll cancel each other out, so it's a 1-to-1 ratio. You could do that. Or you can continue to do the cross method and then get this and then reduce it. Whatever is more comfortable with you. Doesn't matter. Moving on, magnesium phosphate. So we have magnesium, that's on the periodic table. Okay, it's in group 2. Okay, so that's a +2 charge. So magnesium +2, phosphate. If it was phosphide, we would find it here, but it's not phosphide. It's actually on the polyatomic ions list, and it's one you probably should have memorized by now. Phosphate, okay? So it's PO4 minus 3. So this is PO4 minus 3, okay? Now, I usually do the cross method if it's not a 1-to-1 ratio because if I can mess it up, I'll mess it up. But we have, Mg, the 3 was brought down, okay? Then we have, I already know I have more than one of them, so PO4 with a 2. That's it, okay? Cobalt 3 permanganate. So cobalt is a transition metal. It's also one that has more than one charge. If you'll see, cobalt is here. It can be +2 or +3. So cobalt, CO, this Roman numeral indicates which of those charges we see. So it's a +3, okay? Permanganate, that's not on the periodic table, but it's on your polyatomic ions list. Permanganate is down here. It's MnO4 minus 1. So I'm going to write MnO4 minus 1. Then we're going to do our cross method and be done with it. So we have CO, we have the 1, so we don't write it. Mn, we're going to have more than those, so more than one. So MnO4, and we have a subscript of 3. Okay. Silver sulfate. We're almost done with this section. Sorry, getting ahead of myself. Silver is a transition metal, but it only has a one possible charge, which is +1. So silver is Ag +1. Sulfate, okay, sulfate is not on here. If it was sulfide, then we would look at sulfur, but sulfate is a polyatomic ion and one you should have memorized. So sulfate is here. So we have SO4 minus 2. So SO4 minus 2. SO4 minus 2, okay? So then we just do the cross method, okay? And we have Ag 2, because the 2 came down. And we only have one of these, so I'm not going to put parentheses SO4. You could have put parentheses, it's completely optional. Okay. Lead 4 fluoride. So lead is Pb right here, okay? And it could be a +2 charge or a +4 charge. So in order for us to know which charge, we look at the Roman numeral. So it's Pb. It is a +4 because it tells me right here. Fluoride. So you see that IDE ending. So now I know I'm using this fluorine, which this is in group 17, which has a -1 charge. So fluorine, so F, make sure you don't put FL because that's not correct, but FL with a -1 charge, okay? Then we're going to cross it down. Okay, so then you end up with PB1, but we don't write it, F4. Okay, so that's the first section of the review. Second section is basically the same thing, but now we're going from formula to name. So in A, right here, in A, group 1, in A is sodium. So I'm just going to write sodium. Okay, I can't spell. Sodium. And then BrO3, okay? BrO3 is a polyatomic ion. So you look on the polyatomic ions list. BrO3, here it is. It's bromate, okay? So BrO3, so sodium bromate. This is actually the easier version. That's it. That's its name, sodium bromate, okay? Moving on, we have this and this. So you look at this. This is the cation, this is the anion, the negative part. This is the cation positive part, anion negative part. All polyatomic ions, if you've noticed, if you've looked at it at all, are negative. The only one that's positive is ammonium, okay, in 10th grade. So the only one that's positive is ammonium. So we have, your cation is magnesium, it's Mg, it should be a familiar atom. So it's Mg, so magnesium. And then whatever this thing is, what is that? So we have HSO4. That is on your polyatomic ion sheet, HSO4. So that thing is called hydrogen sulfate. So this would be called magnesium hydrogen sulfate. Okay? So, moving on. This one, you guys should be familiar with most of these. Oh, not polyatomic ions. So this is K. Okay. So K is right here. It's written here. You're going to have this periodic table for the test. So potassium. So the cations, you just say their name. So potassium. Okay. And then whatever this thing is, you just say its name. So that is ASO4. So that's on your polyatomic ion sheet. ASO4 arsenate. Okay. So you would just write the word arsenate. Okay. That's it. You're just naming them. You're just naming them. You will find in ionic compounds that you might have to use a Roman numeral, okay? You will, how do you know when to use the Roman numeral? So we have nickel chloride. Oops, I just gave you the answer. But I didn't give you the full answer. That's fine. We have nickel, Ni. So we find Ni on the periodic table. It's right here. So if you'll see Ni, you'll see that it has a possible +2 charge or a +3 charge. If your metal is not in the S block, if it's in the D block, or this weird transition metalloid area, okay? So in this area or that D block, okay? Check and see if it has more than one charge. If it's like cadmium where it's a +2, oh, can you see that? Cadmium where it's a +2 charge, you don't have to indicate with the Roman numeral. Or silver, you don't have to indicate that with the Roman numeral. But, for example, palladium or nickel or copper, you do, okay? So in this case, nickel, sorry, I'll show you one more time. Nickel has a +2 or a +3 charge. So we need to indicate what charge it is. So we're going to write the word nickel. Okay, we're going to write the word that if your anion is an element, so Cl, which is just chlorine, okay? If your anion, your negative charged ion, is just an element, you call it its name with IDE at the end, so that's chloride. Okay, so nickel, we need to find out what its charge is, okay? So to find out what its charge is, you're looking at the anion. So you have nickel, we don't know the charge. And we have chlorine, which we do know the charge, and we have two of them, okay? So chlorine is a -1 charge, okay? So whatever charge is on the anion side, okay, let's separate this. The charge has to be the opposite on the cation side. So this charge, we have -1, but we have it twice. So our anion side is a -2 charge. That means our nickel side must be overall a +2 charge. Now, we don't have any more than one nickel. So this whole nickel needs to carry that +2 charge. So it has to be a +2 charge in order for this to be a neutral compound. So that's how I know that this Roman numeral is a 2. Let's move on. So we have SrNO2. This is not ammonium, so it's got to be on the periodic table. So now I'm going to look for Sr. I do not see it. Now I see it. Strontium. So strontium is in the S block, so you can go ahead and assume, oh my goodness, you guys cannot see that. Sorry. Strontium is in the S block, so you can just assume that it is a +2 charge. So we're not worried about Roman numerals in this case, okay? So strontium, we're just going to write its name. So strontium. And then we need to know what that thing's called, and that's it. So that thing is not on the periodic table. That is actually on your list of polyatomic ions, and you will find it right here, nitrite. So NO2, so it's strontium nitrite. That's it. Okay. Now you have Ba3P2. So Ba3 or Ba is not ammonium, so it's going to be on the periodic table. So barium is right here. And it's in group 2, it's in the S block, so we don't really have to worry about multiple charges. So it's a +2 charge, so it doesn't matter. What I'm getting at is we don't need a Roman numeral for this. We just called them their names. Barium, that P is on the periodic table, which is right here. Phosphorus. So barium phosphide. Remember, if it is if the anion is an element, then you just change the ending to IDE. So barium phosphide is your answer. Okay, we have a lot of these. All right, so moving on. I think we can skip some because for time's sake. So this is normal. This one is a Roman numeral case, so let's do this one. So FeCO3. Fe is on the periodic table. Fe is a transition metal, so we need to be really cautious. Okay, yeah, it has more than one charge, okay? You see that it could be +2 or +3. That's when you have to have a Roman numeral. When the metal has more than one charge. If it's a transition metal that has more than one charge, we indicate what charge to use. So FeCO3, so we have iron, okay, and we have CO3 is something you should have memorized by now, but CO3 is on your polyatomic ions list, CO3 -2. So we have, oh, I forgot to tell you what the name is. CO3 -2 is carbonate, so you write carbonate. And the only thing you need to do now is your Roman numerals. So carbonate is a -2 charge, so we have our cation side. Oh, I'm sorry, you can't really see. Cation side, and you have your anion side. Okay, so we have CO3 with a -2 charge. Iron, we don't know what charge it is, but we do know we only have one of them. CO3, we only have one of them. Okay, so the anion total charge is -2. That means the cation total charge needs to be +2. We only have one iron atom, so it must carry that full +2 charge. So we can assume that the iron charge is the Roman numeral is Roman numeral is a 2. Let's move on to lead. That is one that has multiple charges, so we'll go on with that one. So lead is right here, okay? So it could be a +2 or a +4 charge. We don't know what charge, so we have to indicate it with a Roman numeral. So lead and NO3 4. So NO3 is on our ion list, NO3. It is a -1, oops, cannot see, I'm so sorry. Nitrate, NO3, it's a -1 charge. So lead, and we have nitrate. Okay, and now we just need to know the Roman numeral. I knew we needed a Roman numeral because it had more than one possible charge on the periodic table and it was transition metal. So now we need to do the whole comparing cation, anion. So we have our cation, anion, okay. Our cation is Pb, and we only have one of them. Our anion is NO3, but we have 4 of them. Okay, NO3 means that NO3 has a -1 charge. Okay, so -1, but we have it 4 times. So that means our anion side is -4 overall. That means our cation charge has to be overall a +4. Now, we only have one lead, so that one lead has to carry all the charge. So that means it would be lead 4 nitrate. Okay. Silver, let's do a transition metal, but it's not part of the, it's not one of the weird ones. So we have AgIO3. So Ag, you should think, okay, that's on the transition metal. Let's overall. Ag is right here. And so let's zoom in a little bit. Ag has a +1 charge. There's only one charge it could possibly be. So we don't have to have a Roman numeral for this, even though it's a transition metal. So we just name it what it is, silver. and then whatever this thing is, okay? So we just find it right here on the polyatomic ions list. So that's IO3. Sorry, can you see? IO3. So we're going to call that what it is, and it is iodate, okay? So silver iodate. That's it. That's its name, okay? We don't have to put a Roman numeral because it only had a +1 charge possible. Moving on, this one should be simple. This one is copper. So let's look on the periodic table where copper is. Copper is right here, okay? So if you'll zoom in, you'll see that copper could be +1 or a +2 charge, okay? So copper could be +1 or a +2 charge. So we're going to figure out what charge it is. So first you can go ahead and write copper. You can go ahead and write that that's sulfate, so SO3. I'm sorry, that's actually sulfite. So it's sulfite, SO3. You find it SO3, so that's sulfite. Now we need to indicate which charge we're using for copper, if it's +1 or +2, using Roman numerals. So sulfite, if you'll notice, can you see? Sulfite has a -2 charge, okay? So we know that we're gonna just do C and A, okay? Ca for cation and anion, okay? So copper we don't know, but we know we have 2 of them. Sulfite, we only have 1 of them, okay? But it is a -2 charge. So we have a -2 charge overall on this side. So that means we have to have a +2 charge overall on the cation side. So we have 2 copper ions to distribute this +2 charge. So that means if this was a +1 charge and we had it twice, that would actually equal the overall charge it should be. So that way you can assume that it's copper 1 sulfite, okay? Let's see. We can keep going and do some more with Roman numerals if you're a little confused. So we'll do a couple more on this section, but I don't want to do every single one. You guys, again, have your answers online. Let's do one. Let's do S, okay? This one is one that would be Roman numeral. So we have copper, 2, and then we have 3 of these. So we find copper on the periodic table, okay? Copper is right here in the transition metals. You can tell that it has more than 1 possible charge. It could be +2 or +3. So we're going to write its name, copper. We don't know which charge yet. We have to figure that out. And then what is this thing? Let's find out what that is, okay? That is on your polyatomic ion list, dichromate, okay? So dichromate has a -2 charge. We can go ahead and write it. Sorry, dichromate. Okay, and so now we're going to do our whole little cation, anion thing, okay? So copper over here, we have 2 of them. Dichromate, so Cr2O7, okay? We have 3 of them. So the anion, since dichromate is a -2 charge, so we have -2 charge here. We have it 3 times, okay? So that means our overall charge is -6, okay? Copper, okay, we have 2 of them. The overall charge has to be a +6, okay? So what could be multiplied by 2 to make a +6 charge? So the only, oh no, I'm such a dork. I'm doing copper when it's CO is cobalt. I bet y'all were screaming at me on the screen. Anyways, copper is not copper. Wow. Cobalt. My bad. Cobalt. So cobalt, if you will look here, we were looking at the right one. You even saw oh my gosh, I bet y'all are like getting a headache. Anyways, so cobalt, my bad. So what charge could be multiplied by 2 to make a +6? So that would be +3, obviously. So that means it would be cobalt 3 dichromate, okay? So cobalt, so we are actually going to, in this case, be using the +3 charge here. Should have stopped while I was ahead. Okay, we'll do one more, and then we kind of need to move on. Let's do another cobalt one so I can redeem myself. So we have cobalt, okay? We all know on the periodic table from the last question that it could be a +2 or +3 charge. So we don't know yet. It depends on what this thing is doing. So this is PO4. So let's find PO4 on our polyatomic ions list. That's PO3. PO4 is phosphate. So it's a -3 charge. Okay. So phosphate, we're going to go ahead and write it before we forget. Phosphate. So we're going to do our little chart thing. Okay. We have this cation and we have an anion. We have cobalt. We only have one of them, okay? We have phosphate, PO4, and we only have one of them. So phosphate, so technically it's a 1-to-1 ratio. So whatever this is, you could just say it equals that. So phosphate has a -3 charge. So you know that this charge is -3 one time. That means the overall anion side charge is -3. So cobalt, since we only have one, if we have a +3 charge, then the overall cation side is +3, so we're good. So that means the cobalt will actually be using a +3 charge again. Okay? So basically, if it's ionic compound and you see this transition metal in the question, look on your periodic table. If on the periodic table you find that whatever element you're looking at has more than one charge possible, then you need to find out what charge that anion is, how many of those charges, and make sure that the compound is neutral, okay? So that's how you do ionic compounds, both transition metals and non-transition metals, okay? Now let's move on to here. Molecular compounds. This is the one that's like super easy. So don't forget your, what's it called? Your prefixes, okay? You need to know your prefixes. What mono, di, tri, I don't know, tetra, you know, all of those from 1 to 10, you need to know your prefixes. So silicon tetrabromide. So we're basically writing the formula from a name. So again, if there's only one of that first element, we don't put monosilicon tetrabromide. You would just put silicon. So silicon, we only have one. Silicon on the periodic table is right here. So the symbol is Si. I'm not going to show you every symbol because at this point you guys can either on the test find the word or you should be pretty familiar with where all of the elements are. So we have silicon and then we have tetra. Tetra is the prefix of 4, okay? So we have tetrabromide. So bromide is Br, okay? And we have 4 of them. Okay, so silicon tetrabromide, that's how you would figure that out. Diselenium, so selenium, we'll do the first couple with the periodic table. Selenium is here. It doesn't matter really where it is, but you're really looking to see what the symbol is. So selenium is Se, okay? So selenium is Se, and we have the word di, so that means 2, okay? So we have 2 seleniums. Hexa is the prefix for 6. Fluoride is the name for this element right here, so fluorine, okay? So Se2F, and we have 6 of them, okay? We do not, make sure you don't get ionic compounds and molecular compounds confused. We do not reduce these. Keep them the way they are because there's actual bonds between them. We don't reduce them to an empirical formula. We keep them the ratios that they are. Moving on, phosphorus. So there is no prefix, so we're just going to write its symbol. Pentachloride. Penta is the prefix for 5. And chloride, chlorine, you should be pretty familiar with that one. Okay, so you would write the 5 as the subscript after the element that it's connected to. So we have arsenic heptaoxide. So arsenic is on the periodic table. These are all going to be on the periodic table. So arsenic is here. So its symbol is As. So it doesn't say monoarsenic, but we know there's only one because there's no other prefixes. So we know there's only one of them. Hepta is the prefix for 7, okay? And oxide is just oxygen. So we know there's 1 arsenic and 7 oxygens, okay? Moving on, sulfur, just its name, okay, or just its symbol, sorry. Tri is the prefix for 3. We have oxygen, okay? And then we have 3 of them. Tetra, prefix for 4. Deca, prefix for 10, okay? So now we just have bromine and we have iodine, however you say it. So we have bromine and we have 4 of them. We have iodine and we have 10 of them, okay? Diiodine, nonachloride. So we have di, which means 2, nona, which is the prefix for 9, iodine, we have 2 of them, chlorines, we have 9 of them. Oxygen dichloride, so there is no mono in front of it, but it's assumed, so we have 1 of them. Di is the prefix of 2, so we have oxygen, 1 of them, chlorine, 2 of them. Easy. Now we're going to name these molecular formulas, okay? So now, which is just, honestly, just as easy. The ionic compounds is probably the most difficult part of naming. Acids are a little odd, but it's not as many rules to know. You only have to have know 3 rules. So we have, we just do the prefix and their name. So the prefix here is 3. I'm going to go ahead and zoom in a little bit. So this is sulfur, okay? So sulfur, we have sulfur, and we have oxygen, but since it's the second one, it's going to be called, oops, I didn't say room, sorry, oxide. So we just do our prefixes now. So it's trisulfur, nona oxide. I didn't leave room for that, but my bad. Trisulfur, nona oxide. This one, since it's the beginning of the formula, we don't put mono, we just put silicone. Excuse me. Then we have iodine, but we have 4 of them. The prefix for 4 is tetra. So silicone, tetra, io, but we don't have iodine, it's iodide, okay? All right, moving on. We have di and we have hexa, okay? So we're going to say disulfur, hexa, chloride, okay? We have 1, but we don't write mono here. We have 7, so that is the prefix of hepta. So you just say iodine, you just say its name, how it is, on the periodic table. And then bromide will be the ending. Hepta will be the beginning. So it'll be iodine, hepta, which is the prefix for 7, bromide. Okay. Now we have antimony. This is the weird one that I always throw in on the test. Antimony is SB. Okay. So you would just write can't spell, moni. And then tri is the prefix for 3, chlorine, but it's actually, there's a suffix, chloride. Okay, moving on, we have a prefix of 4 and a prefix of deca. So then you just write their name. So we have tetra, phosphorus, and then deca, oxide. Okay. Then we have nitrogen, but we don't put mono because it's the first one. So we would just say nitrogen. We have 3. The prefix of that is trichloride. Okay. This is AS, and you find it on the periodic table. That's the arsenic. Okay, so you would write arsenic. We wouldn't write monoarsenic, just arsenic. And then this is penta. So arsenic, penta, fluoride. There's a U. I always want to do that. Fluoride. That's UO. My bad. Okay, UO. And then we have here, there's tri and 8 is octa. So we have tricarbon, octahydride. Okay, so instead of octahydrogen, it's octahydride. All right, and then we have not monoteryllium, but just tellurium. Sorry. Doesn't matter, as long as you can spell it and read it off the periodic table. As the prefix for 6 is hexa. And then chloride. That's it. This is very easy. It's probably the easiest part of the test, in my opinion. All right, now we have naming acids. This is kind of in between on difficulty level, just because it is kind of awkward to name these. But there's only 3 rules to naming them. Remember, if it ends in, sorry, I'll go ahead and bring this down. If it ends in IDE, okay, then you have high, ic. If it ends in ATE, you have whatever it is, and then just ic, acid. And then if it ends in ITE, it's whatever the name is, OUS, acid. Okay, so let's move on. And hypo, oh my gosh, what am I thinking? Okay, so hydro for hydrogen, my bad. So hydro, blank ic acid, or just ic acid, and OUS acid, okay? So whatever it is, whatever that second part is, that's what the ending was. This is more for like this number 7 part, but still I was just kind of reminding you. So number 6, write the formulas. So chloric acid. So we have this chlor part, okay? So we know we're dealing with chlorine, okay? So we know we're dealing with chlorine, but I mean, what were we dealing with? We're kind of working backwards. So we have, IC. So whatever the rule is, it was IC, okay? So ic acid is what we're dealing with. So it ended in 8. So we have chlor, and the ending was 8, okay? So it was chlorate. So now what you need to do is find out what chlorate is, okay? So chlorate, if you look on your polyatomic ions list, chlorate is here, ClO3 with a -1 charge. So ClO3 with a -1 charge. So that's how you find out what we are dealing with. What anion are we dealing with? We have always in our formulas that we're writing, it's always going to start with an H+1, always, okay? So in this case, we're going to basically just bring down our charges like we did with the ionic namings. We're going to just bring it down, and here. You're going to see a pattern. Whatever this is, that's really the only thing we're going to change. Because all of our cations are hydrogen, they're all +1 charge, so every one of these are going to be 1, so we don't really write anything here. We're only going to write whatever is here. Whatever the charge of the anion is, that's what we write underneath the hydrogen if it's not 1. So in this case, it is 1. So our formula is literally just HClO3. That's it. Okay? Now, we have, you can put, since it is just one of them, optional, whatever, hydrobromic acid. So we have this hydro and we have this ic, okay? So let's look at our rules. We have a hydro and we have ic, okay? This is ic but without the hydro. So we have hydro and ic. That means whatever that word was ended in ide. So we have brom. So we are dealing with bromide, okay? Which if it's bromide, that's not on the polyatomic ions list. This is just bromine, okay? We're just dealing with bromide. Remember, the elements end in IDE, ide, the anions do, okay? So we were just dealing with Br, That's it. So Br is in group 17. Group 17 all have a -1 charge. So Br -1. The first of any acid, oops, you cannot see. Br -1. The first of any acid always has a hydrogen. They're a 1-to-1 ratio, so the formula is literally HBr. Phosphorus acid. Okay, so we have this OUS at the end. So now we're going to look at our little chart, OUS acid. Okay, so ITE, we have OUS acid. Okay, so that means that whatever it is ended in ITE. So we're going to write phosphite. It ended in ITE. ITE is not on the periodic table. If it was phosphide, it would be on the periodic table, but it's not. It's phosphite. So that means we need to look here on our polyatomic ions list, phosphite, PO3 -3. So we know that it was PO3 -3. And always starts with an H, okay? So this will go here. 1, we don't really write it. So our formula will literally be H, and this is brought down. So H3PO3. That's it. Chlorous acid. So we have this OUS ending. We look at our rules, OUS ending. It ended in ite. So it started with chlorite. It's not chloride, or else we'd look on the periodic table. It's chlorite. So that means it is over here on our, if you can't see, on our polyatomic ions list, chlorite, and that's ClO2 with a -1 charge. So ClO2 with a -1 charge. The other side is always hydrogen with a +1 charge. The charges cancel out. So we have HClO2. That's it. Bromic acid. So the ending is IC. We're going to look at IC. That means it ended in 8. So it was bromate. Okay. Bromate, since it's not bromide, it's not on the periodic table, it's bromate. So we're going to find our bromate, and that is right here. And it's going to be BrO3 -1. So BrO, oops, that's a big O, 3 -1. Okay, then we have always our hydrogen, 1-to-1 ratio. So the, what's it called? The formula is just HBrO3. That's it. All right, name the following acids. So basically we're doing the same thing, but we're doing the opposite. So we have our, basically we're going to find out what the anion is called, change it to the ending we're supposed to change it to, and that's it. So we have this thing. This is, well, if I can pick it up, is a polyatomic ion, arsenate. Where is it? I don't even know where it's at on. Oh, here it is. So it's arsenate, okay? ASO4 with a -3 charge. So it was 8, okay? So arsenate. If it ended in 8, we're going backwards now. We change it to IC. So it is arsenic acid. Okay? We have ClO2. Let's find ClO2. Okay? ClO2. So right here. So that was chlorite. So the ending was ITE. Okay? So ITE, that means we just changed the ending to OUS. So that was chlorous acid. Okay? We have F. That is just an element. So that's going to end in IDE. So fluorine is going, that's in the ending, if it's an ion, which it is in an acid, it's going to end in IDE. So when you see a single element, it ends in IDE. Oxide, fluoride, chloride, bromide, iodide, sulfide, phosphide, okay? All of those ending in ide, that's what the single elements are. So this is fluoride. So it ended in IDE. So it ended in IDE, so it's hydrofluoric acid. Okay, so hydrofluoric acid. Okay, next one, we have HS. Let's see what that thing was named after. Okay, so this was named prior, let me find it, HS. So right here, HS. So that was bisulfide. So it ended in IDE. So we're going to look at our rules. It ends in IDE. So it's going to be named hydro, and it was called bisulfide. So hydro. Hi. Do you need me?
No,
Oh,
don't
okay.
stop because you will have to edit.
Yes, I will. Okay, so we have hydro bisul, and we're changing the ending to IC acid. Then we have this last one, HClO3. That's not an element, so it's on our ions. ClO3 right here. So it ended in ATE, ATE, okay? So if it ends in ATE, here's our rules. It ended in ATE, we just changed the ending to IC. So it is, we don't say hydro, okay? Sorry, ATE, IC. So it's just, I already forgot where we were. Chlorate, what? Chlorate. ClO.
No, it's hypochlorate.
Oh, it's ClO. Hypochlorite. Okay. So it's just hypochloric acid. Chloric acid. Lost my train of thought. Okay. So that's it. We're done, Mr. Arsenicos.
Should I stop?
Yeah, you can stop it.
Red button.